Hi, welcome to Studio Touch. My name is JC and I'll be your guide for about the next hour or so as you explore circuits and software. Now you notice on the Studio Touch in front of you that there's a button on the top called Pause and Play. This button allows you to advance the videos as you move through levels on your Studio Touch. You can feel free to press this button anytime that you finish your circuit and you want to move on to the next level. When this screen appears, press the button to pause the video so that you can work on the circuit. Once you feel comfortable moving forward, press the button again to resume playing our video. So without further ado, let's begin learning about circuits. Welcome to your first lesson of the day on completing a circuit. Now, within a circuit, there are several components. You can visualize a battery like a power plant. It supplies power to our homes, but only if there's a path for the energy to flow. You can see right here that there's a break in the line. Now, electrons are what flow through a circuit to allow you to light your houses. So for energy to get from the factory to your home, you have to have a path. You can do this by adding a wire in a circuit and allowing the energy to flow through it and light your house. For our second lesson, we'll talk about switches in a circuit. A switch is a very powerful tool. It allows us to control the flow of power from our battery to our light. We don't want our lights on all the time, so we have to be able to cut off this path. The switch enables us to do this by allowing us to either complete the circuit as such, or to break the circuit so that power can no longer flow through the wire and turn on our lights. So from now on, I'll be using a battery and a light rather than a power plant and a home to explain a circuit. As I move along, I'll get closer and closer to actually using a real circuit diagram. Now, before we conquer part 3, I'd like to address a very important topic, and that is resistors. Resistors are incorporated in almost any circuit. And basically, resistors control the amount of energy that the electrons have entering the light. You can kind of think of it as a mountain. The higher the resistance, the higher the mountain. The electrons have to travel up this mountain, and they lose a lot of energy in the process. So when they finally get to the light, the brightness isn't as intense. When you have a low-level resistor, you make the mountain a small hill, the electrons easily get over this, and the light is much brighter. Now we are going to focus on more complex controls in a circuit. You have a slide dimmer, and essentially this gives you the power to control this resistance. This is adjusting the height of that mountain, the amount of energy that the electrons have entering the light. So when you slide the dimmer up, you're increasing the resistance and you're making the light dimmer. All right, we're getting to some pretty interesting stuff here. We are moving on to the last panel on the first side of our Studio Touch. And we're going to introduce to you your very first interactive input. It's the bend sensor. Now, it's very similar to the slide dimmer in which it allows you to adjust the resistance, right? That's just the height of our mountain, the amount of energy of the electrons getting through to our light bulb. But what differs between the slide dimmer and the bend sensor is your physical activity that causes this effect. By bending the sensor, your physical actions are altering this circuit. Now, as we move along, we'll encounter more unique and creative ways to alter the circuit, but for now, it's responding to the amount that you bend it from its original state, and that results in the brightness of our LED light. Alright, you've just completed side 1, but before we move on to side 2, I'd like to recap all of the things that you've already learned with Studio Touch. This is your very first circuit diagram. But don't be worried, this is all components that we have already gone over. This is just the representation of them. This symbol right here represents a battery, and it goes from negative to positive. It flows in the clockwise direction because it goes from negative to positive, but it's not always necessarily in the clockwise direction, as we'll see later, but that's not important right now. Next we have a switch, which you've already hooked up. We see here that it is off because there's no contact here and there's no path for the electrons to flow. Now, if this were to turn down and make contact, then we would be able to light our light bulb. Next is a resistor. These squiggly lines are kind of the representation of a resistor, but don't worry about it. You can just think of it as the giant hill that the electrons lose their energy in before they get to the LED light. Now, the reason that it's important for electrons to lose their energy in certain cases is that they don't burn out the light. If it's getting too much energy, the bulb may burst, and that is bad. So it lowers the energy of electrons through the resistor, travels to our LED light. This is the goal. This is the end. We need to light this light. So this is the important part of the circuit. The electrons go through here, create light, and then they loop back around into the battery and cycle through again. Good luck on part 2. I'll see you then. Welcome to the second side of your Studio Touch. There's going to be a lot of interesting topics that we're going to cover on this side. I've kind of developed a new system for the circuit because there's already a lot of stuff that you've learned from the first side, and that is in purple or maroon, whatever you want to call it. The stuff that we haven't seen yet is in black, kind of like an unlocked character in a video game. So this first panel is introducing us the first time to microcontrollers. They're a very powerful tool that allow you to do a lot of intricate stuff when you're designing whatever you want. They're separately powered, so rather than having a battery, we have a power source going directly to this. That's where the power is coming from. You have a bend sensor or a pressure sensor. It's up to you, it's your choice, to complete the circuit. Then we have our microcontroller. What happens is that it gets an input from our circuit, from over here, what you're doing, interacting with your sensor. The input goes through this. It is programmed. We wrote up a program on our laptop and uploaded it to the microcontroller, and then it would give us some kind of output. That would be a result in the NeoPixel. You can see the program's result on this NeoPixel ring. What this is a bunch of LEDs. It's no more complex than the other side, except that there are now 24 of them rather than 1. The manifestation that we have like some kind of program running here is what's going on with this. So say that you're putting a lot of pressure on this and there's not much current going through your input. Well, the output is telling this NeoPixel ring to go around really slow. So you have like colors like rotating around this, and it's going really slow because it's not receiving a lot of current. Say, however, that it is receiving a lot of current. It's going around really fast. Your blues and greens and reds and purples are going around really fast in your NeoPixel ring. But that's not the only example of a function. We could also have said that maybe only a certain number of LED lights light up with conjunction to how much current we're receiving. So there's a low current going through, and maybe only like 1 or 2 of these are lighting up. Then say we release the pressure sensor, and this is just going crazy. All of these are lighting up around here because it's receiving a high current. So this microcontroller takes an input, reads a voltage or a change in voltage, and it gives us an output that we preset based off of that voltage. It's kind of like a function. You put in your x and you get out your y. So y equals x squared. You put in 1, you get out 1. You put in 2, you get out 4. It's the same way. You put in your current and you get out a signal that is sending to your output. Welcome to the second panel. We're going to be discussing capacitors. They're part of a simple circuit, and they have a very interesting function within the circuit. So here we don't have a complete circuit. There's a lot of charge stored up in this battery. We complete the circuit and our charge starts flowing through. Initially, our capacitor acts like a wire. The charge is flowing through here and really not anything interesting happens. But there's a dielectric film between these two plates. It could be glass or ceramic, and it starts storing up charge. Now this looks kind of like a power source, but our power source would have alternating short and long lines. This just has 2 long lines. After a long time, the charge completely fills up the capacitor, and nothing more can flow through, and it kind of acts like a broken wire, kind of like this was cut off. But say we do cut this part of our circuit off, we have a lot of charge here and nothing here, so it's going to kind of be pushed and act like its own circuit. This little ring right here will kind of act like its own separate circuit, separate from this. This will begin acting like a battery, pushing charge out here because of the vacancy in the wire. And then once all the charge is used up, then pretty much nothing will run, just as if we cut off the circuit. Welcome to the third panel of your second side. For this portion, we're going to be covering the topic of motors. Motors are everywhere. They're in our cars, they're in sewing machines, they even run inside of computers, they blow the little fans inside your laptops. But first, we're going to talk about potentiometers. They're very similar to resistors, that's why they have a squiggly line here, and normally they're only drawn as resistors, but for the sake of clarity, I drew the circle around them to highlight that they're not quite resistors. We can alter the resistance by spinning the little dial. They kind of act like a sensor where you're changing the input to change the resistance, but here it's actually built into your circuit to change the dial. And then on this other side we have the motor. Normally in a circuit diagram it's drawn with as a circle with accompanying arrows. This shows that there is some kind of motion here. Motors take in an electrical input and create a mechanical output. So by putting energy into the motor, it starts spinning the little cross blades you see on the outside. It just takes in electricity and puts out a mechanical function. Alright guys, this is it. This is the last panel of your Studio Touch. I'm really sad that this is going to be the end of the tutorials. You're going to have to figure out the other two sides on your own. Previously I talked about motors being in your cars, sewing machines, computers, fans, clocks, pretty much anything that moves. But here for this panel we're going to cover the applications of motors. And we have a fan, a very basic function of a motor. Everything else you notice is in purple. We've covered everything else besides this fan. And really we've even covered the fan because it's just a motor powering a bunch of spinning blades to create a flow of air. Right? So our energy comes in, it converts it into mechanical energy by spinning the blades. We have our potentiometer controlling the resistance. We don't have a sensor in this one, it's just input output. So we have this battery and we're just basically completing the circuit here, which I'll use a purple marker for. We're just completing the circuit here at the bottom. And we can control the resistance and then see how that changes or affects the speed of the fan.